right, so in your handout on the first page, we're going to talk about double angle formulas. And if you've studied any amount of trigonometry, especially if you take calculus, you buy a calculus textbook and you look inside the front cover, I mean, there are a lot of formulas in trigonometry. Okay? A lot of formulas. And so we're just going to hit one class of formulas that gets used a lot in calculus, and that's the double angle formulas. And so they're given at the top of page 1 of your section 4.5 handouts. So in these formulas, x is an angle. So you know when we take the sine of x or cosine of x, we're taking the sine of an angle, cosine of an angle. 2x is then an angle twice the size of x. Okay? That's all 2x means, right? It's an angle twice the size of x. So this can be proven. The sine of the angle 2x is equal to 2 times the sine of the angle x times the cosine of the angle x. And then the cosine of the angle 2x is equal to cosine x squared minus the sine of the angle x squared. Okay? So remember, this is cosine x squared. This is sine x squared. Okay? And then using the Pythagorean identity, cosine x squared plus sine x squared is equal to 1, which we learned about in section 4.2. Using that identity, we can rewrite the right-hand side up here as 2 times cosine x squared minus 1, or we can rewrite it as 1 minus 2 times sine x squared. So all three of these on the right-hand side will give you the same value of cosine 2x. Okay? There aren't 3 values for cosine 2x. There's only 1, and each of these formulas will give you the same value for cosine 2x. Okay? You use the one that's convenient for you. So in the first exercise, we're given that the sine of the angle x is equal to minus 1/5, where the angle x is greater than pi radians, but less than 3 pi over 2 radians. So that's pi radians same as 180 degrees, 3 pi over 2 radians same as 270. So the angle x is in quadrant 3. Right? Quadrant 3 is where the angles are between 270 or between 180 and 270 degrees, or pi radians and 3 pi over 2 radians. So given this value of the sine of the angle x, calculate the cosine of 2x and the sine of 2x. So the sine of the angle x is equal to minus 1/5, with the angle x in the third quadrant, right? It's greater than pi radians, but less than 3 pi over 2 radians. All right. So we know what the sine of angle x is. So it's really straightforward to calculate what the cosine of the angle 2x is by using this third formula down here for cosine of 2x, right? It's equal to 1 minus 2 times the sine of x squared. So using that formula, if cosine of 2x is equal to 1 minus 2 times the sine of x squared, and sine of x is minus 1/5. We square that, right? So this is sine of x squared. This is sine of x is minus 1/5, so we got to square it. Well, minus 1/5 squared is 1/25. And now we gotta, we're just doing arithmetic at this stage. 1 is the same as 25/5. And then minus 2 times 1/25 is minus 2/25. And 25/25 minus 2/25 is 23/25. So the cosine of 2x is equal to 23/25. Now to calculate the sine of the angle 2x, we know the sine of x, but we got to figure out what the cosine of x is. So we got some work to do on the side before we can calculate the sine of 2x. Okay. Well, angle x is in the third quadrant, and we know in the third quadrant, right, the cosine function is negative in quad 3. So to figure out what cosine x is in the third quadrant, right, what the value of cosine x is, I'm going to use the Pythagorean identity. Cosine of x squared plus the sine of x squared is equal to 1. And so I substitute minus 1/5 in for sine of x, and now we just got to solve for cosine x. Minus 1/5 squared is 1/25. And then when I subtract 1/25 from both sides, I get cosine of x squared is equal to 24/25. And then when I take the negative square root of both sides, remember cosine of x is negative. So cosine of x is equal to the negative of the square root of 24/25. And when I take square root of the numerator and square root of the denominator, well, I guess I left it like that. Okay, so this is, no I did. So when I take the square root of the numerator, square root of the denominator, I have square root of 24 in the numerator, and square root of 25, is 5. I can reduce this numerator, square root of 24, but not right now. Okay. And so now I can calculate the sine of the angle 2x, which is equal to 2 times the sine of the angle x times the cosine of the angle x. Well, the sine of the angle x is minus 1/5, and the cosine of the angle x is minus the square root of 24 over 5. And now I'm just multiplying three numbers, okay? And so, negative times a negative is positive. And so I have 2 times the square root of 24 over 25. And now I can reduce the square root of 24. 24 is equal to 4 times 6. The square root of 4 is 2. 2 times 2 is 4. So the sine of 2x is equal to 4 times the square root of 6 over 25 after we reduce the radical in the numerator. Okay. So any questions on that? Yes, ma'am.
You put the negative in front of the cosine because it's negative in the third quadrant, right?
Yep. Cosine's negative in the third quadrant, and x, angle x is in the third quadrant. That's between pi and 3/2 radians. Okay. All right. So if you flip over your page, you can do one more. So we're given the cosine of the angle x is equal to square root of 3 over 5, where the angle x is between 3/2 radians and 2 pi. Well, that's quadrant 4. Right, that angle's in quadrant 4. And cosine is positive in quadrant 4. That's why cosine x is equal to a positive number. But we also, now that we know that x is in quadrant 4, we know that the sine of x is negative in quadrant 4. So to calculate the cosine of 2x, right, you only need to know the cosine of x to do that. We can use this second formula for cosine of 2x. It's equal to 2 times the cosine of x squared minus 1. So cosine of x is equal to square root of 3 over 5. And now you gotta do arithmetic. That's all it is, arithmetic at this stage. Square root of 3 over 5 squared is the same as 3/25. Then we'll put square on that. Okay. So 2 times 3/25 minus 1. And so 2 times 3/25 is 6/25. And then 1 can be written as 25 over 25. And then cosine of 2x is equal to minus 19/25. So that's the easy part. Now we got to find the sine of 2x. And to do that, we got to figure out what sine of x is equal to. but we know it's negative in quad 4. So using the Pythagorean identity, cosine of x squared plus sine of x squared is equal to 1. Cosine of x, square root of 3 over 5. And square root of 3 over 5 squared is 3/25. And now I subtract 3/25 from both sides. And 1 minus 3/25 is equal to 22/25. We just said sine of x is negative in quad 4, so we're going to take the negative square root. And we get the sine of x is equal to the negative square root 22/25. And when I take the square root of the numerator over the square root of the denominator, I get sine x is equal to negative square root of 22 over 5. And now we can calculate the sine of 2x. It's equal to 2 times the sine of x times the cosine of x. And so the sine of 2x, right, is equal to 2 times minus root 22 over 5 times root 3 over 5. Now it's arithmetic. So positive times negative times positive is negative. Now 22, same as 2 times 11. So root 22 times root 3 can be written as root 66, right? 22 times 3 is 66. So we have 2 times the square root of 66, and then 5 times 5 is 25. So the sine of 2x, sine of the angle 2x is equal to the negative, is equal to minus 2 root 66 over 25. Any questions? Yes, ma'am.
Is there a reason why you dropped the sine of x squared over there?
I dropped it.
Like there's no square. Like it's just sine of x instead of sine of x squared.
Like here?
No, over there at the bottom.
Oh, I took the square root of both sides.
Oh, okay.
Right? I took the square root. But more specifically, I took the negative square root.
Okay.
Right? Because sine x is negative in quad 4. And this angle x is in quadrant 4.
Okay.
Okay. Any other questions on double angle formula? Okay. All right. So back in section 4.2, you don't have to dig these notes out. You can just look at the overhead. On the last page of your notes, right? We solve 2 trigonometric equations, right? This is a trigonometric equation. Sine of t is equal to root 2 over 2, and cosine of t is equal to minus root 3 over 2, right? Those are two examples of trigonometric equations. And we solved those two equations for the angle t, where the angle t had to be between 0 and 2 pi radians, okay? So today, we're going to solve some trigonometric equations that are quadratic in form, okay? And so in your handout, right, examples A, B, and C, the trigonometric equations are quadratic in form. And so in A, you can see it's quadratic in form because we have 2 times the sine of x squared minus 3 times the sine of x plus 1. Right, that's very similar to the quadratic equation 2x squared minus 3x plus 1 is equal to 0, right? I just replace sine of x with x, and I get 2x squared minus 3x plus 1 is equal to 0. We know how to solve this, right? We factor, could use the quadratic equation, but this actually factors. This factors into 2x minus 1. Yep. Times x minus 1 is equal to 0. And then we solve for it, right? We use the zero product property to solve for x. That's what we're going to do with these trigonometric equations. We're going to factor them, use the zero product property, and then solve each equation for the variable x. Okay? Now you may want, if you have your unit circle handy, you might want to get it out. If you don't have one, I got a couple extra up here. And so we're going to find all the angles x that we can put in for x in this equation, this trigonometric equation, and the left-hand side equals 0. Okay. And so the first thing we're going to do is find all the angles x that satisfy this equation, all the angles x on the unit circle from 0 to 2 pi radians. And then from that, we'll be able to expand our solution to all angles that satisfy that equation. Okay? So we have 2 times the sine of x squared minus 3 times the sine of x plus 1 is equal to 0. So, following what I wrote on the board over here, this factors into 2 times the sine of x minus 1 times the sine of x minus 1. Okay. The only difference between that over there and this over here is I have x instead of sine of x. Okay. Now by the zero product property, either the first factor is equal to 0 or the second factor is equal to 0. And now we solve for sine of x, technically not for x, right? Now we're going to solve for the sine of angle x. So in this first equation, right, we add 1 to both sides and then divide by 2. And we get the sine of the angle x is equal to 1/2. And then in the second equation, we just add 1 to both sides. And we get the sine of angle x is equal to 1. So like we did back in section 4.2, see these equations now, right? These two equations here look like the one back in the last page of section 4.2, right? We just got the sine of the angle x is equal to a number. back to page section 4.2, the number on the right hand side was square root of 2 over 2 instead of 1/2 or 1. Okay, but we found the two angles where the sine of those angles is equal to square root of 2 over 2. Now we're going to find the sine of two angles that are equal to 1/2. Okay, we're going to find the sine of any angles that are equal to 1, right? So now we're basically we're at the stage where we're going to do what we did on the last page of section 4.2. Okay. Well, from the unit circle, we know that the sine of pi over 6 is equal to 1/2. And we know the sine of 5 pi over 6 is equal to 1/2. So those are the two angles on the unit circle where the sine of those angles is equal to 1/2. Now for sine of x equals 1, there's only one angle in the unit circle where the sine of that angle is equal to 1, and that's pi over 2. So the solution to our trigonometric equation for angles on the unit circle between 0 and 2 pi radians is x is equal to pi over 6. I'm going to do these angles from smallest to largest. X equals pi over 6. X equals pi over 2. And x equals 5 pi over 6. Those are the three angles that will make the left-hand side of our trigonometric equation up here equal to 0. Okay. Those are the three angles on the unit circle. We want all angles that will make the left-hand side equal to 0. Okay. And what we know from section 4.2 is that angles that are coterminal, they have the same value for the sine function, same value for the cosine function, so forth, right? So if I add 2 pi to this angle, I get a coterminal angle, and the sine of pi over 6 plus 2 pi is also equal to 1/2. Okay? If I subtract 2 pi from this angle, okay, the sine of that angle is also equal to 1/2 because they're coterminal angles. I just handed back your quiz, right? And you were given two angles, one in radians, one in degrees, and you had to find an angle that was coterminal with it, right? So coterminal angles, right? The sine function has the same value for coterminal angles. Okay. So if we add an integer multiple of 2 pi to this angle, the value of the sine function for all those angles will equal 1/2. And if we add an integer value of 2 pi to this angle, the value of the sine function for all those angles will equal +1. Okay? So to get the general solution for all angles, we got to add an integer multiple, the k is an integer multiple of 2 pi. And you know, integers are 0, plus or minus 1, plus or minus 2, and so forth. Okay. So adding an integer multiple of 2 pi to any of these angles doesn't change the value of the sine function. Okay. So the general solution can be written as pi over 6, right? For this equation right here, the sine of x equals 1/2. the general solution can be written as pi over 6 plus 2k pi, where k is an integer. Any integer, okay? Any integer. The general solution for the sine of and so we added for pi over 6, right? We add an integer multiple of pi. We do the same thing with 5 pi over 6. Adding an integer multiple of 2 pi to 5 pi over 6, the sine of all these angles is also equal to 1/2. Okay? Because they're all coterminal angles. Okay? And then if we add an integer multiple to pi over 2, where k is an integer, the sine of all those angles is equal to +1. Okay? Because all these angles are coterminal. When you add an integer multiple of 2 pi to pi over 2, you create a coterminal angle, and the sine of that coterminal angle is equal to 1. Just like the sine of pi over 2 is equal to 1. Okay? And this all gets back to the periodicity of the sine function and cosine function, how they repeat their values every 2 pi radians. Okay? And so this is the solution. Okay? First, we find the solution to the equation on the unit circle, and then we write out all the coterminal angles to the solution on the unit circle. Okay? Any question? I tried to slow it down, right, in explaining this, not rush through it. Are any questions on that? You understand coterminal angles? When you add 2 pi or subtract 2 pi from an angle, you create a coterminal angle, right? And that doesn't change the value of the sine function or the cosine function when you do that. All right. In B, we have 2 times cosine x squared minus 3 times cosine x minus 2 is equal to 0. Again, this is in quadratic form. Factoring the left-hand side is like factoring 2x squared minus 3x minus 2. And that factors, on the left-hand side, that factors into what? 2x times x minus 2 and plus 1, right? 2x times x, 2x squared, minus 4x plus 1x minus 3x, 1 times negative 2. Okay? So this, our trig equation over here, factors into 2 times the cosine of x plus 1 times the cosine of x minus 2. Instead of x, I have cosine of x. Okay. And now, using the zero product property, either the first factor is equal to 0 or the second factor is equal to 0. Well, in this first equation, when I solve for cosine x, where I subtract 1 from both sides, divide by 2. And I get cosine of x is equal to minus 1/2. In the second equation, I add 2 to both sides. And I get cosine of x is equal to 2. Well, before we write out the 2 angles from the unit circle where the cosine function is equal to minus 1/2, if you look at the right-hand side, we have cosine of x is equal to 2. But we know the range of the sine function and cosine functions from minus 1 to plus 1. 2 is greater than plus 1. There's no angle you can take the cosine of and get plus 2, because plus 2 is not in the range of the cosine function. So there's no solution to that second equation. But the first equation, that's where in a unit circle is the cosine function equal to minus 1/2? Well, the cosine of 2 pi over 3 is equal to minus 1/2. And the cosine of 4 pi over 3 is equal to minus 1/2. So those are the 2 solutions on the unit circle. X equals 2 pi over 3, and x equals 4 pi over 3. If you put in pi over 3 in for x in our original equation, the left-hand side will equal 0. You put 4 pi over 3 in for x on the left-hand side of our equation, the left-hand side will equal 0. But we need to know all the angles that we can put in for x, and the cosine of those angles will equal minus 1/2. So to get all the angles, we just add 2k pi to each of these 2 solutions. So 2 pi over 3 plus 2k pi gives us all the angles, okay, that are coterminal to 2 pi 3, and the cosine of those angles is equal to minus 1/2. And then we add 2 pi over 3, or 2k pi to 4 pi over 3. And that gives us all the angles that are coterminal with 4 pi over 3. And the cosine of all those angles is also equal to minus 1/2. Remember, k is an integer. So that's all the angles that put in for x in the original equation make the left-hand side equal to 0. Okay. All right. Any questions on that? Okay. So if you flip your paper over, I'm going to help you get this one set up. And we'll do what we can, but I'll leave it for you as a brain teaser. See if you can come up with the final solution over the weekend. So we have the cosine of x squared plus 1/2 the sine of x minus 1/2 is equal to 0. Okay. Now if you look at this, this is going to be quadratic in form, but we're mixing trig functions, aren't we? Right? It's got cosine x and sine x. And so we got to rewrite this so that we only have either sine x or cosine x in the equation. Okay? What do we do? Well, somebody going to say something?
Would you use cosine x squared plus sine x squared equals 1, and rearrange that.
Yep.
To solve for cosine x squared and substitute in sine x squared.
So Brian's on the right track. We have the Pythagorean identity, cosine x squared plus sine x squared is equal to 1, right? We're actually going to substitute for cosine x squared. So we subtract sine x squared from both sides of this equation, and we have the cosine of x squared is equal to 1 minus the sine of x squared. So now I substitute for cosine of x squared. I have 1 minus the sine of x squared plus 1/2 the sine of x minus 1/2 is equal to 0. And now my equation has only sine x in it. Okay. Now 1 minus 1/2 is plus 1/2. But 1/2 minus the sine of x squared plus 1/2 the sine of x, right? I'm just combining like terms. Now I want to get rid of these fractions. So to clear the fractions, I can multiply both sides by 2. And so when I distribute the 2 inside the parentheses here, 2 times 1/2 is 1. And then minus 2 times the sine of x squared plus the sine of x. And 0 times 2 is still 0. And now I can write this in descending powers of sine of x. And I have minus 2 times the sine of x squared plus the sine of x plus 1 is equal to 0. Now you can factor this. Now some of you are comfortable factoring with a negative number up front, right? So this is like factoring minus 2x squared plus x plus 1 is equal to 0. But I've told you many times this semester, I don't like factoring where the number in front of the squared term is negative. So I like to divide both sides by -1 and change the sign of the coefficients, right? And so when we do that, we have 2 times the sine of x squared minus the sine of x minus 1 is equal to 0. Now this is like examples A and B on the previous page. So see if you can come up with the general solution to this problem over the weekend, okay? And we'll compare answers on Monday. Okay? So have a good weekend. Be sure to have some fun because finals are next week.